Seafloor spreading. What are mid-ocean ridges? When scientists were making maps of the ocean floor, they made a surprising discovery. In certain places, the floor of the ocean appeared to be stitched together like the seams of a baseball. Scientists found that the seams formed mountain ranges that ran along the middle of some ocean floors. Scientists called these mountain ranges mid-ocean ridges. Mid-ocean ridges form long chains of mountains that rise up from the ocean floor. In the mid-1900s, scientists mapped mid-ocean ridges using sonar. Sonar is a device that uses sound waves to measure the distance to an object. Scientists found that mid-ocean ridges extend into all of Earth's oceans. Most mid-ocean ridges lie under thousands of meters of water. Scientists also discovered that a steep-sided valley splits the tops of some mid-ocean ridges. The ridges form the longest mountain ranges on Earth. They are longer than the Rockies in North America and longer than the Andes in South America. What is seafloor spreading? By the 1960s, geologists had learned more about mid-ocean ridges. They learned that mid-ocean ridges continually add new material to the ocean floor. They called this process seafloor spreading. Seafloor spreading begins at a mid-ocean ridge, which forms along the cracks in the oceanic crust. Along the ridge, new molten material from inside Earth rises, erupts, cools, and hardens to form a solid strip of rock. When this sinking and rising motion continues, it is called a convection current. Convection simply means heat transfer by the movement of material, the rock or the hot rock in this example. Seafloor spreading adds more crust to the ocean floor. At the same time, older strips of rock move outward from either side of the rock. This rock, or crust, creeps only a few centimeters a year. The image above shows evidence that geologists have found for seafloor spreading. Scientists drilled into the ocean floor to obtain rock samples. They found that the farther away from a ridge a rock sample was taken, the older the rock was. The youngest rocks were almost always found at the center of the ridges. Recall that at the ridge center, molten material erupts and cools to form a new crust. The rock's age showed that seafloor spreading had taken place. What happens at deep ocean trenches? Does the ocean floor keep getting wider without stopping? No. Eventually, the ocean floor plunges into deep underwater canyons. These canyons are called deep ocean trenches. In a process taking tens of millions of years, part of the oceanic crust sinks back into the mantle at deep ocean trenches. The process of subduction. The crust moves away from the mid-ocean ridge. It becomes older and denser. And eventually this older, denser crust may collide with the edge of a continent. Gravity then pulls the older, denser crust down beneath the trench and back into the mantle. The process by which the ocean's floor sinks beneath the ocean trench and back into the mantle again is called subduction. Seafloor spreading and subduction often work together. They move the ocean floor as if it were on a giant conveyor belt. Subduction and the Earth's ocean. Processes of subduction and seafloor spreading can change the size and shape of the oceans. Because of the processes, the ocean floor is renewed about every 200 million years. That is the time it takes for new rock to form at the mid-ocean ridge, move across the ocean, and sink into a trench. The sizes of Earth's oceans are determined by how fast new crust is being created at mid-ocean ridges, and how fast old crust is being swallowed up at deep ocean trenches. An ocean surrounded by many trenches, may shrink. An ocean with few trenches will probably grow longer. For example, the Atlantic Ocean is expanding. This ocean has only a few short trenches. As a result, the spreading ocean floor has almost nowhere to go. The oceanic crust of the Atlantic Ocean floor is attached to the continental crust of the continents around the ocean. Therefore, as the Atlantic Ocean floor spreads, the continents along its edges also move, and over time, the whole ocean gets wider.